Hi, this video is to show you how to compute the fixed order quantity model with safety stock. Okay, this is from our slides about inventory management. And just to remind you, in the previous videos, I showed you how to compute the optimal quantity order in the fixed order quantity model. But in this case, we don't have safety stocks. So we move one step further in this process and we add safety stock levels to our inventory management, to our reorder point. So this is what I'm going to show you how to do it. Just to remind you, this is one illustration about placing orders. Every time we place an order, this order will be in the amount of the optimal order quantity we compute. Let's say 300 units. So the stock is going down, and then we place an order, and then we have our inventory going up in 300 units. And then the company starts using inventory to produce products or to sell in stores, and then the inventory starts going down, and then it reaches a point where we have to reorder to our suppliers. And then while we wait, that's the lead time, while we wait for the supplier to deliver, then our inventory is going down. And sometimes we sell more, sometimes we sell less, sometimes we produce more, sometimes we produce less. We don't know how much to produce because demand varies. So this is the reason we have the safety stock here. We're going to add a safety stock to not stock out at certain probability. Remember our class on um, sales order and order management? That's the same idea. So I'm going to have a safety stock that's going to protect me for certain probability of not stocking out. Okay, and then the reorder point formula is going to be this one. So this is the reorder point formula we're going to be using with the safety stock model. Okay, so let me show you an example. This is the fixed order quantity model with safety stock from our slides. And what we have here is some pieces of information. Okay, I'm going to use Excel to start like putting this information here. So our average daily demand is our D bar, that's 60. Our annual demand is our capital D, and this is equal to the average daily demand multiplied by 365 days. If the problem doesn't say how many days we have in a year, we use 365. So that's the annual demand. We have the standard deviation during lead time. This is one new piece of information from in this problem, standard deviation of demand during the lead time. So during the lead time, during the time we're producing, or during the time we're waiting for the supplier to deliver the raw material or the products, we have a certain demand, but this demand varies. So the standard deviation tells us how much the demand varies. So there is a variability. That's the standard deviation. This is also illustrated by a Greek letter sigma. So let's call sigma D. Let's call sigma D, that's fine. And this is, according to the problem, standard deviation of demand, sigma D is equal to 7. So I'm taking notes of the problem to help me. So the order cost is also called S, and the order cost is 10. The holding cost is 50 cents per unit per year. That's H. And we have some additional piece of information like the lead time. So the lead time, our L, is 6 days. So this is how long it takes for the suppliers to deliver the product. And also, even though the problem doesn't list here, we want 95% probability of not stocking out. In the next problem, when you're gonna practice, you're gonna see that. So this is the probability of not stocking out. So let's call that not stocking out, not stocking stocking out probability. I'm going to use the decimal notation instead of 95%, 0.95. Okay, and then I'm going to have a z, which is the z value associated with the not stocking out. So this is our z. This is something new that I want to show you. To compute the z value associated with a given probability, you type equal norm.s.inverse inv, that's the formula, and then you open parentheses, and then you select the probability in the decimal format, and you type enter, and that's the z value associated with the probability of 95% not stocking out. Okay, so you have all pieces of information you need. Here is the two formulas. I'm going to compute the optimal order quantity. The optimal order quantity, the first part is 2ds, that's inside the formula, so it's 2 times multiplied by the annual demand multiplied by the order cost, and then I have 2ds divided by age. I already did 2ts, so I have to get that and divide it by age, and now I take the square root of above, so it's the square root of what I have above here, is equal SQRT open parenthesis square root of above. So this is every time I place an order, every time I place an order, I order 936 units. So this is what these slides have, 936 units. Now let's compute the reorder point, considering the safety stock. Now is reorder point with safety stock. So the reorder point with safety stock has different pieces. So let's start computing the bar multiplied by L. Let's do this. So this is my average daily demand multiplied by my lead time. So this is my demand during the lead time. Okay. Let's see. Okay. So I did wrong. So my d bar multiplied by my lead time. That's what it is. Okay. D bar multiplied by lead time, and this lead time is 6 and not 7 days. I'm sorry, 6 days. Okay. So going back, lead time 6 days. Okay, so my demand during lead time is 360 units. So this is the average demand during the lead time. And now I'm going to compute this other piece here. First, I'm going to start computing the variability of demand during the lead time, which is this formula here. Okay, this is a new formula. Let me copy that and paste here. So to be able to compute, okay, to be able to compute the sigma L, what I need is the square root of L multiplied by sigma D squared. So let's just start with the sigma D squared. So how to compute sigma D squared, or standard deviation of demand squared, is equal to standard deviation of demand during the lead time square, which means multiplied by itself. So that's the sigma D squared. Okay, going back to the formula, sigma D squared. Now I'm going to multiply by L. So sigma D squared multiplied by the lead time, that's equal to this. So I'm multiplying the sigma sigma d square by the lead time. So that's the variability. Sigma d squared is nothing more than the variance. The variance during the lead time. The variance during the lead time is 294 units. Okay, and now I take the square root, square root of above to not write too much. So that's equal to square SQRT, open parenthesis, this number. So that's the variability during the lead time. So this is the variability. It's called the variability of demand during the lead time. So we have the average demand. We have the variability of demand, average and variability. Now, just to remind you, this is just this part of the formula. So the square root of above is the sigma L, okay? So this is the sigma L. Now I have to multiply sigma L by Z. So I mean, sigma L is equal to this, just to make it clear to you. Now Z multiplied by sigma L. So now I want to cover 95% of this variability. That's what I'm doing here. I want not to stock out 95% of the time in the variability. So what I'm going to do is I'm going to compute the z value associated with 95% multiplied by the sigma L. I can select this or this, they're both the same. So this is the variability during the lead time. So this is, let's say, the units covering, this is the units necessary to cover 95% variability during the lead time. Okay. Okay, so how much will be my reorder point finally after all this computation? So my R, which is my reorder point, is going to be equal to my Z multiplied by sigma L plus my D bar multiplied by L, which is 399 units. So this is my reorder point. Every time my inventory reaches this level, reaches, let's say, 389 units, I have to place an order to, let's say, to be able to not stock out 95% of the time, considering this lead time and standard deviation of demand. Okay, so this is what it is. We computed the order. Every time we place an order, we order 936 units. If we're considering the reorder point with safety stock, every time our inventory reaches 388 units or 389, we place an order. That's how you compute it.